everyone. Welcome to lab number 5. I am back at Simmons today, and today I'm going to be synthesizing aspirin and running a TLC plate with my synthesized aspirin and aspirin from the pharmacy, just regular aspirin tablets. So I'm going to share my screen and show you what I will be doing today. So here we have synthesis of aspirin. So aspirin is called acetyl salicylic acid. If you've ever worked in healthcare or seen an abbreviation of aspirin, maybe someone in your family takes aspirin daily, it's abbreviated ASA. So ASA is the acetyl salicylic acid. So acetyl is A, salicylic S, and then acid A. So ASA. Usually people take 81 milligrams, so sometimes you'll see ASA 81 milligrams on someone's medical history, but that is what you abbreviate aspirin as. So the reaction I'm going to be doing today to produce aspirin, and I'll call my aspirin my synthesized aspirin, and then the regular aspirin, just aspirin. So synthesized aspirin is what I'm making, and aspirin is what is in this bottle. So I'm going to be taking salicylic acid, which is pictured here. It's just a white powder. It's in a lot of skincare products for acne, or acne is, I think that's really the only use for it in skincare products that I can think of. So I'm going to be taking salicylic acid and acetic anhydride, which I have to have in the fume hood because it's very strong. It's a very strong chemical. So I'm going to be combining some salicylic acid powder with acetic anhydride, and I'm going to be using an acid catalyst. So I don't think you've gone over catalysts yet in lecture, but a catalyst is something that speeds up a reaction. So I'm going to be using phosphoric acid, which is a really strong acid, and that's going to be my acid catalyst in this experiment. So it's denoted as a H+ here above the arrow. So what that means is I'm going to be taking salicylic acid, mixing it with acetic anhydride, and in the presence of an acid catalyst, which is that H+ there, phosphoric acid, I'm going to be getting aspirin and acetic acid are my products. So those are my reactants, and my products are going to be aspirin and acetic acid. So I'm going to scroll down here. I'm also going to perform a ferric chloride test. So if you remember the last time I was here in lab, I did a bunch of tests for functional groups. So one of them was the ferric chloride test. It was the Sunny D looking solution there. So I'm going to use my ferric chloride solution and test for phenols. That was the use of ferric chloride solution last time. So I'm going to test for phenols in salicylic acid and also my synthesized aspirin. So if you notice here, the salicylic acid does have a phenol present. My synthesized aspirin product should not give me a positive test. It should remain that orange color because aspirin does not have a phenol present in its structure, unlike salicylic acid, which does. So I'm going to be doing all of these steps here to synthesize my aspirin product. And I think it would be helpful to just follow along the steps, because just in case I don't show you, I'm not going to show weighing out salicylic acid. I've already done that. So if I don't show one of the steps, I might just show what the vial looks like. You'll be able to know, like, oh, I just heated that in the water bath. So just follow along with these steps. And eventually I'm going to need to vacuum filter my synthesized aspirin. So I'll definitely show the setup of the vacuum filtration. So what we do with the vacuum filtration is we have to place the synthesized aspirin in a funnel, and we use airflow to extract all the liquid from it. It's like we vacuum the sample and we vacuum out the liquid in the sample. So only the solid will remain. And I'll also need to wash my synthesized aspirin with really cold water. I actually have some water sitting in an ice bath. So it needs to be very cold because I don't want to dissolve my synthesized aspirin. If I used warm water, I would start dissolving the crystals, that synthesized aspirin crystals, and I don't want that. And I wash it with my ice cold water to neutralize any of the remaining acid that might be present in my synthesized aspirin. So that's why the washing is an important step. So then I'll vacuum filter my synthesized aspirin and I'll perform the ferric chloride solution test on it and compare it to salicylic acid. And then I'm going to run a TLC plate of regular aspirin and then my synthesized aspirin product. So I'll be using the silica gel coated plates. And I'm also going to use 1% acetic acid and ethyl acetate. We've talked a lot about hexanes with TLC, but depending on the solutes that you're using, you need to use certain solvents. So the experimental procedure for TLC of aspirin is you would use 1% acetic acid and ethyl acetate as your solvent. So what I'll be doing is I'll dissolve my regular aspirin and my synthesized aspirin in 1% acetic acid and ethyl acetate. And I wrote here, so the stationary phase is the TLC plate that's coated in the silica gel and it's extremely polar. My mobile phase is not going to be hexane, it's going to be the acetic acid and ethyl acetate, and it's 1% acetic acid, so it's actually mostly ethyl acetate, and it's less polar. So it's not as non-polar as hexane, but compared to the silica gel, I wrote here, comparatively non-polar. So it's a lot less polar than silica gel. So the concept is pretty much the same, even though the solvent isn't the same as what we saw last week. So then I'm going to view my TLC plate under UV light, and aspirin should have an approximate RF of 0.8. So hopefully my synthesized aspirin has a similar RF. So hopefully you remember how I'll be calculating the RF. So the distance that the spot moves over the solvent front, how far the solvent goes up the TLC plate. So here is just the process that I'm going to be doing for that. I'm going to add a spatula tip amount of my synthesized aspirin to a test tube, and then I'll add 1 to 2 milliliters of my 1% acetic acid and ethyl acetate, and then I'll do the same with my regular crushed aspirin and add 1 to 2 milliliters of 1% acetic acid and ethyl acetate, so that I have 2 separate test tubes. And then I'm going to prepare my developing chamber, which will look the same as what we saw last week. And I'll mark my origin line, spot the plate using my capillary tubes, which look like this. Remember I said that they're like a straw for a hamster? They're just so small. So those are my capillary tubes. I'll cover the chamber and let my 1% acetic acid and ethyl acetate rise up my TLC plate, and then I'll remove it from the chamber, let it dry out in the fume hood, and then visualize it under my UV light. So I'm very hopeful about the TLC experiment. However, I only have a finite number of, is it finite? Yeah, finite, not infinite. Yeah, so I only have a limited number of TLC plates, and that's all I could find in the stockroom. So hopefully I can do this experiment once, maybe twice, and not use up all my TLC plates and get the results that I hope for. So what I'm going to be looking for are the spots of my synthesized aspirin are going to look similar to my aspirin. And if they don't, if there's extra spots, then I'm going to assume that my synthesized aspirin is impure. There might be leftover salicylic acid, there might be leftover acid or acetic anhydride, there might just be leftover something in it. and it'll show up as multiple spots on my plate. So let's get started. I'll go put on my PPE and I'm going to begin by synthesizing my aspirin here. All right. In the fume hood, I mixed my 0.28 grams of salicylic acid powder with 0.6 milliliters of acetic anhydride and 2 drops of concentrated phosphoric acid. So I swirled it around, and now I'm going to put it into this hot water bath and just let it stand there, and I'm going to leave it for 8 minutes, and I'll occasionally swirl the vial just to make sure all of the salicylic acid dissolves completely. Okay, I'm all done with my water bath, and we can see that my solution is no longer cloudy, so all of the salicylic acid has dissolved. I'm going to add 0.5 milliliter of water to get rid of any excess acetic anhydride. So I'm gonna shake it around, and I'm in the fume hood because if there's any acetic anhydride still present, I don't want to be doing that outside of the hood. So I'm gonna let that sit for a minute, and then I'm gonna take it over to my bench and add another 0.5 milliliter of water to my vial. Now I've added 1 milliliter total of water to my vial, and I see that there is some crystallization happening, which is great. I'm going to place the vial into an ice bath and let it sit for 10 minutes before I vacuum filter it. Here is my vacuum filtration setup. I have a filter flask, a funnel, a Buchner funnel, I think it's called, a neoprene adapter, which fits into the neck of the flask. I have my vacuum intake going here, and it connects to my filtration flask, and I'm holding it all together with this clamp setup. So what I'll do to get my vacuum filtration setup going is I'll take a piece of filter paper here and I'll put it into my funnel. So if you see the funnel there, there's all these little holes. So what that looks like when you just put some water in is the water runs through those holes. So these holes are a little bit too large for me, and I don't want to lose any of my product. So I put a filter paper there, and I'll wet it. And then I'm going to turn on the vacuum so you can see what it looks like when this is vacuuming. I turn on the vacuum here, and you can hear the airflow. And I'll spray with some water, and the water is vigorously coming out through the funnel there. So that is what I'm going to be adding my synthesized aspirin to. I just removed my vial from my ice bath, and it's looking good. So it did crystallize in the ice bath, and now I'm going to vacuum filter out the crystals, so there's only a solid that remains. So I just emptied the contents of the vial into my funnel, and now I'm going to turn on the vacuum and get the airflow moving. Okay, so we see some of that liquid being extracted there, and you already see it drying out quite a bit. There we go, that's a good picture. So to my funnel, I'm going to add this ice cold water. I'm gonna add 2 milliliters total. You see the ice cold water going through the funnel. I'm gonna add a little bit more because the first pipette wasn't exactly 1 milliliter. So I'll add a couple more drops of my ice cold water. Now I'm going to let this sit for about little less than 10 minutes. So I'll do 8 minutes. I'll pause this video and check back in after 8 minutes of vacuum filtration. I forgot to add, I actually am going to just scrape my filter paper a little bit first because the filter paper can get too saturated and it's almost as though it gets clogged, so it doesn't dry out as well as I would like it. So I'm going to, it's been about a minute, I'm gonna just gently scrape this. And now I'll wait the remaining 7 minutes for it to dry out. All right, it's been 8 minutes of vacuum filtration, and here is my synthesized aspirin. So now I'm gonna perform a phenol test on my synthesized aspirin and a crushed aspirin tablet that I just crushed with a mortar and pestle. I just mixed 1 spatula tip full of my crushed aspirin tablet with acetone and my synthesized aspirin with acetone. So my synthesized aspirin dissolved really well. My crushed aspirin tablet did not dissolve very well. It looks kind of chunky. So I looked at the ingredients of the aspirin tablet and it has cornstarch, talc, some other dibasic calcium phosphate. These are all inactive ingredients in my aspirin. So I'm wondering if the cornstarch, the talc, give me that residual white material there. But now I'm going to do a phenol test with my ferric chloride, and I'm going to actually do the phenol test on a piece of filter paper so it's easier to see. So I just added a drop of my synthesized aspirin solution. So it's the synthesized aspirin mixed with acetone. And I applied it to the ferric chloride drop and I see that it's turning purple. So that tells me that there is still salicylic acid present in my synthesized aspirin. So it is not pure. It's giving me a positive result for the phenol test. My crushed aspirin didn't really change, so I know that there is no phenol present in my crushed aspirin sample. So that was the crushed aspirin with acetone, and I applied it to a drop of ferric chloride solution. So my synthesized aspirin is not considered a pure product because there's still salicylic acid present. is my developing chamber. It's a beaker. There's a watch glass on top. I cut a piece of filter paper in half, and then I use these tweezers to submerge them into my 1% acetic acid in ethyl acetate, which is my developing solvent. And then I stood them up resting against the sides of the beaker so they can act as that wick and make the whole beaker filled with vapor of my 1% acetic acid and ethyl acetate. So now I'm going to carefully put my TLC plate standing upright, and I'm going to make sure that my solvent does not touch my origin line on my TLC plate. I tried to quickly take a photo as soon as I put the TLC plate in to show you that my solvent was below my origin line, and it's quickly rising, so I had to be really fast about taking the picture, but luckily the solvent was far below my origin line, and so now I put the watch glass on top and I see this 1% acetic acid and ethyl acetate. It's slowly rising up on my TLC plate. And then when it gets closer to the top, I'm going to take it out. So when it's maybe 1 or 2 centimeters from the top, I'm going to remove the TLC plate, draw a line on the TLC plate because that's my solvent front. I'm going to bring it over to the fume hood to dry out, and then I'll visualize it using my UV light. Hi, it's 10:46 p.m. I ran 7 different TLC plates and didn't get good results, so that's pretty unfortunate. I tried a lot of different things. I noticed that the solvent wasn't moving up my TLC plate very quickly. It was taking a long time, so I used a smaller beaker. I used a 400 milliliter beaker instead of a 600 milliliter beaker. I used fresh everything. So I used fresh development solvent, which is the acetic acid in ethyl acetate. I made fresh reagents or solutes. So I used fresh aspirin and fresh synthesized aspirin. I used a bigger wick, so a larger filter paper, to see if maybe the solvent wasn't moving very quickly because of the lack of vapor. Maybe the chamber wasn't filled with vapor. I also wanted to just try a beaker with hexane in it, even though I knew that my spots weren't going to move in hexane because they are polar, they're not nonpolar, and hexane is nonpolar. So as I expected, the spots didn't move. So I guess that's one positive of the experiment, in that the spots did what they were supposed to do. So they're too polar to move in hexane, and they just stayed where they were. So that's it for the lab. I think that the synthesis went well. I think my aspirin looked like fresh aspirin when I took it out of the vacuum. So that's great. And if you're ever in a similar situation, like in a lab or at work or in life where something's not working out, it might just be bad luck. So I could come in here tomorrow and maybe the TLC would work, and you just never really know why. So hopefully I can do some research and see if there was anything I was doing wrong and report back and include it in this video. But that's all for tonight, and I hope you enjoyed Lab 5, and I'll see you in Zoom. Bye.